everyone. I hope you're doing well today. As you can see, Beaker is he's settled down. He's come to grips with it being socially isolated here at the house a little bit, and he's lost the mask, he's lost the gloves, so he's feeling better now. A little interesting. I got an email from Mr. Engel, who works in the central office, the other day, and he asked me about our pork and bean supplies, and I told him that we don't measure pork and beans around here by the can. We measure them by the pound, and as it stands right now, I think we have 14 pounds of pork and beans, so we're still in pretty good shape. Before we start today's lesson, I want to give you a few quick reminders about coronavirus. I know you're seeing it on the news. I know you're seeing it other places, but I feel personally compelled to give you a few reminders just to make sure you're getting the message. Number one, and most important, wash your hands and disinfect. If you touch something, if you go to the store, you buy some stuff and you bring it home, wipe the cans off before you put them up in the cabinet. Make sure that you are washing your hands frequently, even throughout the day in your own house. You want to make sure that you keep yourself nice and clean. My hands are feeling horrible because I'm washing so much, but better my hands feel horrible than I pick up the bug. Number two, and maybe the hardest one for y'all, is maintain social distance. If you don't have to go out, don't go out. Stay home. The next couple weeks, the government's predicting that the cases are going to peak. As of right now, today, there are no cases in Dade County, Georgia. That's good news. I think there are 7 cases in my county here in Alabama. So it's really important that we keep a little distance just for a little while longer, just to allow things to settle down, allow testing to ramp up a little bit more. It's just a good idea. And as I said during our first video, number 3, get on a routine. Don't spend all day long sleeping. Get up in the morning, read a book, get up in the morning, do some exercises, get up, kind of get yourself a pattern. It'll make you feel better mentally and physically. I think y'all all heard of, or if you haven't heard of, you should have by now heard of Dr. Fauci. He's the director of the National Institute of Allergy and Infectious Medicine. He's one of the main lead people on the coronavirus task force. Dr. Fauci is 79 years old, and he gets up every single morning and runs 3.5 miles. That's his routine. He's working 19-hour days, but he still maintains that routine. And Men's Health did an interview with him last week, and they asked him, Dr. Fauci, you're so busy, you got so much going on. What are you still running for? And his answer was simple. He said it makes him feel good. That maintaining that routine, doing his same stuff that he's always done, makes him feel good. So I'm going to encourage you once again, find a routine, reach out to your friends digitally, do those things that you can to keep yourself feeling mentally and physically healthy. Here is today's lesson. Okay, we're going to take a few minutes here to take a look at friction on an inclined plane. Keeping in mind that this is optional material, I thought it would be interesting for those of you that are really interested. This is one of the harder ends of the friction problem scale, and I know some of you are really interested in preparing yourselves for a college physics course. This would definitely be something you need to understand for that. For anyone else, again, this is completely optional. If you're not interested in it, you don't even have to watch the rest of the video. A few basic notions we need to keep in mind. This is the setup that we're looking at here. So what we have is we have an object on an inclined plane. It has a weight. This here is the force of gravity. Weight is mass times g, 9.8. And that is consistent. No matter what the angle is, no matter how the angle changes, the weight remains the same. But as the angle increases, I go from a low angle to a medium angle to a high angle, the force going down the slope is going to get longer, and the normal force, which is perpendicular to the surface, is going to get smaller. So in normal flat problems, weight and the normal force are equal. But for inclined plane problems, you have to calculate the normal force. Now, when you take a look at this, you might say, well, the normal force is floating up here in space. How do I get it? Well, what you need to realize is that this triangle right here, this leg of the triangle, which is listed here as the force of gravity perpendicular to the surface, there's perpendicular, is equal to the normal force, because this line right here and this line right here are exactly the same length. So we can get this force of gravity going down the slope, which we would normally equate that to, that's equivalent to the applied force. So when I work problems, I usually think of that as an applied force. It's not being applied by an outside entity like a person pushing on it or something, but it is an applied force, that it's a force acting on the object down the slope. It's just coming from gravity. The friction force is exactly as you'd expect. It's just opposing the motion down the ramp. Let me clean this up just a little bit so we can get our formulas in there for you. So this is weight. This angle theta is this angle here. This you can think of as the normal force. It's actually the absolute value of the normal force. And when you look at this one, you can think of that as the applied force. Now, formula-wise, since it's just a simple triangle, we can just skip over a few things here. I know that the applied force is going to equal to the weight times sine theta, and the normal force is going to equal to the weight times cosine theta. Just again, solving this right triangle right here. Keep in mind, very, very careful. The samples we're going to work today, I'm giving you everything in newtons, but remember this force, this W here, has to be in newtons. If it is not in newtons, use the formula weight equals m times g to calculate the mass and convert it to weight. Let's take a look at a typical sample problem. 15 Newton box sitting on a inclined plane. Keep in mind that 15 newtons is straight down, so we have 15 newtons going in this direction. The angle is 22 degrees. The coefficient of static friction, so the non-moving friction, so we're assuming that it's like the box was sitting on level ground and then this was raised up to 22 degrees. And the question is, if it started out level and raised up 22 degrees, will the block slide or not? Well, basically what we're asking is, if I look at this applied force down, again, this is technically the force of gravity parallel to the surface, but we're going to consider it like it's an applied force. Is it less than or greater than the friction force? Well, if the friction force is greater, sit still. If the applied force is greater, it slides down the slope. So let's clear this out and work the problem real quick. Again, quick little note here. I have 15 newtons in the downward direction. I need to calculate this force, and I need to calculate this force. And this is 22 degrees. So we'll start with the normal force, and the normal force is found by taking 15 cosine of 22 degrees, which gives me 13.9 newtons. That is the force going in this direction, up, perpendicular to the surface. The higher it goes, the lower the normal force becomes. The applied force, or the force of gravity down the slope, is going to be 15 sine 22, which is 5.6 newtons. So I have 5.6 newtons down the hill, or down the slope. Now all I need to calculate is the friction force. So the friction force is found by taking mu times the normal force. Mu is 0.43. The normal force is 13.9 newtons. And so I end up with a mu of 5.97 newtons. So the force going back up the slope is 5.97. Well, this force is greater than this force, and so no, it will not slide. No sliding. Problem number 2. Well, we have the exact same situation. I still have the 15 Newton block sitting on the slope. 15 newtons. And the question this time is, as I tilt this up, as I go up, what angle will cause it to start sliding down the slope? What angle would cause it to start sliding down the slope? Now that was a little bit of a problem when you first look at it. This was slightly challenging. Pause the video for about 15-20 seconds. Think about what are the things you need to know and how can we come up with a solution for this one. And then when you come back, I'll work it real quick. Okay, well we're back in the same situation we had before. So I've got forces working on the box. I have what I'm referring to here as the applied force, or the force of gravity down the slope, and the friction force back this way. Now, if these two forces are perfectly in balance, as this goes up, as this thing goes up and up and up, this gets bigger and bigger and bigger and bigger and bigger. This basically is going to get smaller and smaller and smaller and smaller because the normal force is going to go down. And at one point, some specific angle, they're going to be exactly equal to each other. And at that point where they're exactly equal to each other is where I'm going to solve the problem. Once I know where the equal point, then I know any angle greater than that would cause it to slide down the hill. So what I'm going to be looking for is the applied force. When is it equal to the friction force? At what angle? Well, I know the applied force just from the formulas we had a little while ago is 15 sine theta, and the friction force is 0.43. That's the static friction, because that's the one we have to overcome to get it to slide, times 15 cosine theta. Well, I can solve this equation. I can divide both sides by 15 cosine theta, and so I end up with 15 sine theta over 15 cosine theta equals 0.43. Well, 15 and 15 go away. Sine over cosine, if you know your trig functions, sine over cosine is tangent. So tangent theta equals 0.43. I'm going to go to give myself a clear page here real quick. So I have tangent theta equals 0.43. If that's true, then the inverse tangent of 0.43 is equal to theta. Take out my calculator, press the button, theta ends up equaling 23.3 degrees. So any angle greater than 23.3 degrees will cause the block to slide down the slope. You can double check that by putting in an angle of 23.3 and reworking problem number 1, and you will find that the friction force and the applied force, or the force of gravity down the slope, are almost exactly equal to each other at exactly 23.3 degrees. Problem number 3. Now we're changing it up here a little bit. We have a 4 Newton block, and it's on a slope of 31 degrees with a coefficient of kinetic friction. What is the acceleration? So we have to make a little assumption here. When you see a problem like this, you have to assume that at the time that we're doing the problem, that the block is already sliding. You've already overcome static friction and you're into kinetic friction, so the block is already sliding down the slope. And now we want to calculate the acceleration. Well, kind of working backwards, just to kind of get myself situated here, I realize that what I'm going to end up doing here, the final step, is going to take the net force, is going to be mass times acceleration. So I'm going to end up with the acceleration is the net force divided by the mass. So at some point I've got to calculate the mass from this 4 newtons. I know I'm going to need that. And I know that I'm going to need to get the net force. Well, in this case, the net force is going to be exactly what we expect it to be. I'm going to have an applied force, or a force of gravity down the hill. I'm going to have a friction force, and so the net force is going to equal to the applied force minus the friction force. And that will allow me to get the acceleration due to gravity. Well, all the other steps to get to that point are exactly like problem number 1. So I'm just going to do the normal force, which is 4 cosine 31, which equals 3.4 newtons. And I'm going to do the applied force, which equals 4 sine 31, which is going to be 2.1 newtons. And that will give me a friction force of 0.23, that's mu, times my normal force of 3.4, and that gives me a 0.78 Newton normal force. Now, not normal force, so that gives me a 0.78 Newton friction force. So I know this one is 0.78 newtons. And my applied force is 2.1 newtons. So I can calculate the net force equals 2.1 minus 0.78 equals 1.3 newtons. So I'm going to give myself a clear page here, and we've got all of our information, and we'll just transfer some of these numbers over. So I've already calculated my net force to be 1.3 newtons. What I need before I can solve the problem, because I'm trying to get net force divided by mass equals acceleration. So I've got net force of 1.3 newtons. I need the mass as the acceleration, so I'm going to find the mass here. Now what you want to be careful about is we've done normal force equals m times g and kind of rework that to come up with our gravity. You can't do that in this case because the normal force is not perpendicular to the ground, it's perpendicular to the surface. So we've got to use weight equals m times g. Make that a g, there we go. And so we end up with the mass equals weight divided by g. The mass equals the weight, which is 4 newtons, divided by 9.8. And I end up with a mass of 0.41 kilograms. That 0.41 kilograms goes right here, 0.41 kilograms. And when I divide 1.3 divided by 0.41, I end up with an acceleration of 3.17 meters per second squared, which is my final answer. I've posted a few sample problems for you to look at. Though they're technically not graded to go in the grade book, if you submit them, I will grade them for you so you can see how you did on them. I hope you found that lesson informative. That will be your last lesson until after spring break. So next week, we will have no lessons. So enjoy the break. I will probably send out one more video to you on Friday, just a howdy doody or something, I don't know. Something fun. Look for that on Friday, and until then, if you need me, as always, you can reach out to me via Remind or email. As I've said every time we've done these videos, be smart, be safe. Hope to see you soon.